Okay, so the class activity today, okay, we compose of 3 problems, right? The first one is the initial value problem. I think you can do it by yourself. Okay, it's just a Lunge-Kutta method. It's just a little bit review. Okay, in order to find the exact solution, this is not hard because 1 over square root y is equal to this, right? Okay, and dy. And on the right hand side, it's become dx. Okay, after that, we can integrate both sides. Okay, we obtain y. And don't forget, we will have a constant also. And we apply the initial condition. Then we have the constant. And after that, we can solve for the exact solution. Okay, so for the exact solution, if we integrate this term, what happened? It's become 2y like this, right? And it's become x plus 2x squared over 2, right, plus c. Okay, we apply boundary condition. That is when x equal to 0, y equal to 1, right? Okay, so then when we substitute y equal to 1, so then it's become 2, right? Okay, x equal to 0. Okay, so what happened? So then we have c equal to 2, right? Okay, so after that, we solve this equation. So then it's mean that it's equal to x squared plus x plus 2. And after that, we can find y. This is the exact solution. Y is become x squared plus x plus 2 squared over 4. Okay, this is the exact solution, right? Okay, after we have the exact solution, okay, we can create a table of the Lunge-Kutta of the 4th degree, okay, 4th order Lunge-Kutta method, okay, and compare with the exact one. For the first problem, I think you can do it by yourself, okay, and we skip it. Okay, let's consider the second one. The second one is very close to the example that we have learned, right? Okay, but now this is the same equation. It's very close. Okay, and the length is become 1 meter instead of 10. Okay, and we will use h equal to 0.25. Okay, and the boundary condition, when x equal to 0, t equal to 240, right? And when x equal to 1, t equal to 150, right? Okay, so for the central difference, we know that the second derivative is become f xi plus 1, right? Minus 2 f xi, okay, plus f xi minus 1, okay, divided by h squared, right? Okay, and now h is become 0.25. Okay. So for this type is if we draw some pictures, maybe something like this. Okay, we have T1, right? And we have the step. When x equal to 0.25, okay, we have T2. 0.5, we have T3. 0.75, we have T4, right? Okay, and also we have T5. Okay, so now we have just only 3 unknown. After that, for the final, for this activity, we have just only 3 unknown, 3 equation, right? Your calculator can solve. Okay, but if we have more than this, okay, you may apply the Gauss elimination that Ajahn Hwit already teach you. Okay, Gauss elimination, Gauss seidel to solve this system of equation. Okay, so for this case, we will derive the equation first. Okay, from this equation, so what happened? We have ti plus 1 minus 2ti, right? Plus ti minus 1, okay, divided by s squared. Are you right? Minus 0.15 ti, okay, equal to 0. Okay, we know that h is equal to 0.25. Okay, then s squared is equal to 0.0625. Okay, and after that, when we rearrange this equation, it's become ti plus 1 minus 2ti plus ti minus 1, right? Minus, okay, after we multiply s squared both sides, it's become minus 0.009375 ti equal to 0, right? Rearrange this equation again, okay, because we have these two. Okay, we have the equation of minus ti minus 1, right? Plus 2.009375 ti, okay, minus ti plus 1. Okay, you right? Okay, it's equal to 0. You right? After we have this equation, as we can moving to each node. We will moving to each node. Okay, we will consider the node number 2 first. For node number 2, it's become what? Minus t1, right? Plus 2.009375 t2 minus t3 equal to 0, right? Okay, so then this equation we substitute t1 that we already know from boundary condition is equal to minus 240, right? So then this equation is become 2.009375 t2 minus t3, right? Is equal to 240. As we have, this is the first equation, right? Are you right? Okay. So then for node 3, we do the same thing. It's become minus t2 plus 2.009375 t3 minus t4, right, equal to 0. Okay, then it's become what? This is become the second equation, right? We already formed. It is the second one. Okay, and after that, for the final one, okay, for the final, that is the node number 4. For node number 4, we have minus t3, okay, plus 2.009375 T4 minus T5. That is T5. We know that it is a boundary. We have 150, right? So then we obtain the last equation, that is minus T3 plus 2.009375 T4 equal to 150, right? This is the third equation. After that, we can form the equation in the metric form, right? You see that it is the same pattern, right? For the finite difference. Okay. And from this equation, can you solve for T2, T3, and T4? Okay. If it just has three equations, three unknown, you can use your calculator, right? Your calculator, I think your calculator can solve this system of equation with just three equations, three unknown, right? Okay. But if you have four equations, four unknown, you can use the doubt elimination technique. That's Ajahn Thawit already teach you. Or you can use Excel also. The Excel can determine the inverse metric or can solve the linear equation also. You can study by yourself. Okay. So for this case, we just solve this equation, right? So what is it? Who can give me the answer, please? For this case. What is it? Who knows? What is the answer? What is it? Who can help me solve this? Okay, that's fine. The solution of this problem, okay, the solution of this problem is 214.65695.010, right? Okay, and I give you just only one solution. So from only one solution, you can solve another one. This is very easy to find. Okay, so then I will leave it to you. Okay, I will leave it to you. You may solve by yourself. Okay, and then for the last, you see that it's very close to engineering mechanics problem, right? Okay, mechanics of material that you already studied. Okay, you can determine the exact solution by yourself by direct integration and satisfy the boundary like this. Okay, we obtain the exact solution over here. Okay, and we would like to apply the finite difference method to solve this. Okay, to solve this equation. To solve this equation, you see that we have the second order term, second order differentiation term. Okay, so then we have to use this formula. Okay, and after that, do the same thing. Do the same thing. Okay, and collecting the equation, forming the equation, and after that, you will have the equation in the metric form also. for this case, the beam length is equal to 5. We subdivide into 1.25. This means that is four elements. Okay, 4 elements. So then, after that, we will have 5 nodes. Okay, 4 elements, 5 nodes. And at the end, we have the solution already. So then we have just only the middle end, the middle node. That is, we have just only 3 nodes. That's the unknown. Okay, so then the equation after that, we just form 3 equations, 3 unknown, right? So then we can solve for that case. Okay, so I think you can do it by yourself. So for today, it should be enough. Okay, do you have any question?